Hello everyone, my name is Pavitra Anapurpar Paramasivam and my metric number is 33DCE20F2017. Today I am going to do a test about BRINELL hardness. BRINELL hardness test is most commonly used to test materials that have a structure that is too rough or too coarse to be tested using other test methods, example casting or froggings. In BRINELL testing machine, the load is applied by a lever mounted on knife edge and carrying a hanger for suspending the required load. Compared to the other hardness test methods, the indenter used in BRINELL makes the deepest and widest indentation. So here got four specimen material, that is cast iron, mild steel, brass and aluminium. Each of the indenter is 10 millimeter. For the first experiment, we select cast iron and the cast iron load is 3000 kg, and we are going to do each specimen to trial, and the specimen is placed on the supporting table. Then the hand wheel below the table is turned in clockwise direction until the gap between the surface of the specimen and the indentation is 5 mm. After that, we need to turn on the switch and the hand lever is pulled into the position. This is applied for 10 to 15 seconds. After 15 seconds, we need to turn off and unload position back. After that, the diameter of the impression is measured through a microscope attached to the apparatus, and measured diameter is 5.9. So these are the observation, and from here we can calculate the HPW and the average diameter by using the formula. So we are going to do the second trial. So put the same specimen and then turn it clockwise direction until the gap between the surface is 5 mm, same, and then turn on the switch. After turn on the switch, load the hand lever and wait for 15 seconds. After 15 seconds, we need to unload and we need to take the diameter of the it is 6.4. These are the observation for trial 2, and using the formula we are going to get the average and the HPW. Now we are going to do the second specimen, and it is mild steel, and each specimen we are going to do 2 trials. So these are the mild steel load and its weight is 3000 kilograms, same as cast iron, and we need to repeat the step 1 until step 4 for each and every specimen. So as usual, we need to switch on the machine and pull into load position. After 15 seconds, we need to unpull and unload the position, and we need to measure the diagram after the process, and it is 4.6. And these are the observation for trial 1, and this is trial 2. We need to do the same thing, and we need to place it on the table. After that, switch on back and the hand lever is pulled into load position. After 50 seconds, unload back and take the measure. Make sure we need to take all the readings after the experiment. So here are the observation, and these are the observation for trial 1 and trial 2 using the formula. Now we are going to do the third specimen, and it is brass, and for the brass it is 1000 kg, and we need to do the same steps. So switch on back and load back the position. After 15 seconds, we need to unload back this position and measure the diameter. After measure, and these are the observation. Same for trial 2, and we need to do the same step also. After specimen is in position, turn on the switch and load into position. After 15 seconds, the hand lever is pulled into unload position and take back the measurement. So these are the observation for trial 2 and these are overall. Don't forget to use the formula that given. And for the last one, aluminium, and it's 500 kg, and we need to do the same steps for both trial. So yeah, after put in position, turn on the switch and the hand lever is pulled into load position and wait for 15 seconds until the time is over. Unload back the position and measure the diameter. These are the observation for trial 1, and for trial 2 need to do the same step. After that, turn on the switch and hand lever is pulled into load position. After that, wait for 15 seconds and then unload back the position and measure the diameter. And these are the last trial. In conclusion, the objective of this experiment was to find the hardness of mild steel, cast iron, brass, and aluminium using BRINELL hardness test. Based on the result obtained by performing this experiment, we can conclude that the objective was accomplished, despite having small source of error. Mild steel is harder than aluminium. This is because mild steel is more stronger, durable than aluminium due to its high density or weight. It is less likely to bend under force. So from the data we collect and we calculate, we know that mild steel more harder and durable than aluminium. So this is the experiment I have done, and thank you.